to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept.
It was the early 1960s, and President Kennedy had set the stage. Apollo 11, moon landing. It's called Landing Site 2, a section of moon landscape covering roughly 3 by 6½ miles. If all goes as planned, the first Americans will land and explore a portion of this area. Astronauts Neil A. Armstrong, Edwin E. Aldrin, and Michael Collins, the 3 men who will make the next and most historic round trip to the moon. It is Collins who will be in charge of the cone-shaped command module, circumnavigating the moon as his 2 compatriots descend and land on the lunar surface. Born in Rome, Italy, October 31st, 1930, Collins served as pilot during the 3-day Gemini 10 mission in 1966. Astronaut Buzz Aldrin, the lunar module pilot, will fly with Armstrong to touchdown on the moon. It was Aldrin who established a new record for time outside a craft in space, more than 5½ hours during Gemini 12. The 39-year-old astronaut has an impressive background, including a doctorate.
I attended public schools in my hometown of Montclair, New Jersey, received an appointment to the United States Military Academy at West Point. I was commissioned in the Air Force, flew in the Korean War for about 6 months, sent over to Germany flying F-100 aircraft. In 1959, applied for admission into Massachusetts Institute of Technology to study astronautics in greater depth, leading toward a Doctor of Science degree.
That we've never before even thought to ask. And this will be the challenge to the next generation.
Once on the moon, Armstrong and Aldrin will take photographs, dig for lunar soil samples, collect rock specimens, and set up scientific experiments to remain after they have left. To gain data about the moon's interior and meteoroid impacts, they will deploy a device for recording seismic activity. Another experiment will precisely measure Earth-Moon distances. The crew of Apollo 11 have been preceded by 15 unmanned lunar explorers. These first close-up photographs were recorded by a Ranger spacecraft just before it slammed into the moon's surface. Following Ranger, Surveyor, craft which soft landed and verified that a man could walk there. Charting and mapping of mountains, craters, and other surface features was the job of Lunar Orbiter. This high-flying picture taker helped determine the best landing sites for the Apollo astronauts. It's called Spacecraft 107, housing for the 3 men as they fly to the moon and back. The onboard oxygen, water, food, and electricity provide a self-contained bit of Earth environment for the astronauts. The command module is approximately 12 feet by 12 feet in size and weighs 13,000 pounds with the crew at liftoff. Through the years, the Apollo command module has been put through many rigorous tests, some, like this one, to prove its seaworthiness. Connected to the command module is the 22-foot-long service module, weighing 51,000 pounds. In addition to the rocket engine for returning the men to Earth, it holds oxygen supplies and fuel cells. There was no room for error in the development of the spider-like lunar module, which will actually land on the moon. It must do its job. It must be able to descend to the lunar surface, land, and take off at mission's end. This is the craft assigned to that first moon landing. The lunar module is in two parts. The bottom stage, with its descent engine, will lower astronauts Armstrong and Aldrin gently to the lunar surface on a pillar of rocket exhaust. This stage then acts as a launching platform for the upper section, with its ascent engine lifting the two men back up to join Michael Collins, orbiting in the command ship. The combined spacecraft is shown here during final checkout. The Saturn V rocket, which will boost Apollo 11 off the launch pad and toward the moon, is put together inside the vehicle assembly building at the Kennedy Space Center. When the three stages and guidance unit are locked in place for rollout to pad 39A, the giant space vehicle stands 363 feet high, powerful enough to thrust a 50-ton payload into lunar orbit.
Start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour.
Columbia and Eagle were on their way. At stake, nearly 10 years of research, development, and fabrication. Some 20,000 companies throughout the United States participated in the building of the Saturn V rocket and Apollo spacecraft, which carried astronauts Armstrong, Aldrin, and Collins on their historic journey to the moon. Theirs was a journey like no other, for they were the first to set foot on the lunar surface and began setting their scientific experiments. After 22 hours, they headed for a rendezvous with Mike Collins and the trip home to Earth. Because of the possibility of contamination from the moon, the three astronauts were quarantined for nearly 3 weeks. At the same time, scientists began looking at their newly acquired lunar samples, the first opportunity anyone had had to look at something from a different body in the solar system. Samples were given to 142 scientists, both here and abroad, for intensive study. Results will be released in January when the group gathers in Houston to go over their findings. Shortly after returning from the moon, the crew of Apollo 11 began another journey that lasted 40 days. At the request of the President, they embarked on a goodwill mission covering some 46,000 miles with visits to 22 countries. From Mexico City to Brussels, Belgrade to Kinshasa, Bombay to Tokyo. The lunar trio was warmly and enthusiastically received by millions of people, giving them a chance to share their experiences firsthand. Since 1959, 73 men have been accepted into the astronaut program. Here, 9 of those most recently selected take part in jungle training exercises at the Tropic Survival School in the Panama Canal Zone. Although all U.S. astronauts have landed in the ocean after returning from space, the spacecraft are so designed that in an emergency, they can safely come down over land. Since there is a remote possibility that this could occur, all astronauts are taught how to survive in both the jungle and the desert. During their 4-day course in the wilds of Panama, the astronauts were dropped into the water in a swamp penetration exercise. Studied some of the various jungle animals at a zoo set up especially for this purpose. took an overnight trek through the jungle. Chopped down trees for shelter and fuel. Built fires and cooked wild game. And met with some of the local Indians. At a place called Pasco, 100 miles southwest of Spokane, Washington, the astronauts took part in another intensive training course, desert survival. One of the first things the men had to learn was how to build a shelter to protect themselves from the hot sun. A combination of parachutes and life raft seemed to do the job. Improvise is the key word to desert survival. Here they dig a water still. By digging a hole in the sand and covering it with plastic, what little moisture there is in the soil condenses on the underside of the plastic and drips into a container. Even a crash helmet makes an acceptable shovel. Another important technique they learned was how to attract the attention of rescue airplanes. By using signal mirrors and markers, they made themselves visible from overhead. Hopefully, survival training will never have to be used, but should the contingency take place, the astronauts will be well prepared.
Six, five, four, three, two, one, zero. All engine running. Liftoff. We have a liftoff.
Tranquility, we copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. I'm at the foot of the ladder. The 11-foot beds are only depressed in the surface about 1 or 2 inches. I'm going to step off the limb now. That's one small step for man.
Neil Armstrong, Commander Apollo 11. Edwin Buzz Aldrin, Lunar Module Pilot.
Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12.
The two-man missions will be concluded with the next flight, Gemini 12. Astronaut James A. Lovell will be command pilot, his second round trip into space, this time for 4 days. With him, Edwin E. Aldrin, here experiencing weightlessness. His general training has been spent on geology field trips, water escape exercises, qualifying with a parachute, and equipment reviews and practice. Both astronauts will be kept very busy during Gemini 12 with experiments such as a walk in space, weather and terrain photography, even trying to learn if a sextant can accurately chart a course through space. Gemini 12, the last mission before Apollo.
It was during the years following World War I that Captain Charles A. Lindbergh made the first solo flight across the Atlantic, drawing worldwide attention to the potential of the airplane. Dr. Robert H. Goddard successfully developed and fired liquid-fueled rocket motors, events which would influence later history. These were the post-war years. At Langley, wind tunnels were being constructed, wind tunnels able to test models in free flight, making accurate measurements and corrections before a plane was built, pointing the way to improved airplane design concepts. To help determine the spin characteristics of aircraft, a spin tunnel was so designed that models could be spun simulating full-scale free flight. This same facility was used also to test out models of all of the manned spacecraft, Mercury, Gemini, and Apollo. During the second decade at Langley, 1927 to 1937, the dirigible, plagued by a series of tragic accidents, and the biplanes faded from the scene. In their place, the all-metal single-wing craft, predecessors of our commercial airlines, planes with 2 rather than 3 air-cooled engines and retractable landing gear. The NACA was asked to determine the conditions which caused ice formation on aircraft and develop means of preventing it. These studies grew into a major effort that did, in fact, find a solution with the 1946 awarding of the Collier Trophy for the pioneering research. To serve the needs of the seaplane and amphibious airplane designers, the first of Langley's hydrodynamic test tanks were made ready for operation. Towing a model hull through the water up to the point of a simulated takeoff speed, engineers could suggest improvements in the basic design. In later years, Mercury, Gemini, and Apollo water landing techniques would be checked out using the same tank. World War II dominated Langley's third decade. The urgency of the war dictated the programs of this period. Programs aimed many times at curing the immediate ills of already flying combat aircraft. Typical of these were the ditching studies. Here, a highly instrumented B-24 was crash-landed in the James River. Research aimed at giving over-the-water combat crews a better chance of survival should they be forced down. Other work during the wartime period included studies of airplane stalling characteristics. aircraft loads in maneuvering flight, and problems associated with diving and braking. Near the end of the war, Langley scientists were working on the idea of wing sweepback, an idea for attaining higher flight speeds. One method of experimentation was with rocket-propelled models. These early studies can be seen in present flying airplanes. High speed presented some problems of ejecting from an airplane. This test pilot was subjected to wind tunnel blasts at speeds up to 400 miles per hour to check human tolerance. October 1947, Captain Charles E. Yeager, piloting the Bell X-1, flew through the speed of sound for the first time and pioneered the way to supersonic flight. Speeds made possible by the long research effort that had begun early in the war at Langley. The next decade, 1948 to 1957, research continued on the X series of aircraft. These included the X-3, X-5, and the most significant airplane design, the X-15 hypersonic research aircraft, shown here being proved out in a Langley wind tunnel. Today, the X-15 travels at speeds in excess of 4,000 miles per hour and is returning information about high-speed, high-altitude flight as it maneuvers close to the fringes of space. Research and flight tests of helicopters continued to take place to help determine future designs. A landing loads track began operation during this period. With it, aircraft landing gear could be subjected to the same type of load stress encountered during landing. Later tests identified the problem of aircraft and automobile hydroplaning as a result of water-drenched pavements, a condition that can cause loss of control. Speaking about his years in aviation, General James H. Doolittle, former chairman of the National Advisory Committee for Aeronautics.
This is my 50th year in aviation. I started in 1917. In those days, the airplane was very simple. There was a stick and wire contraption covered with cloth, and if somebody had drawn a picture of a modern-day airplane, we would have thought him slightly mad. Perhaps the best way to explain what's happened in aviation is to say that in those days, there was a fixed landing gear, simple engine, simple airframe. Since then came flaps, slots, retractable landing gears, jet engine, air conditioning, pressurization, and all of the multiple manifold communicational and navigational equipment, all the military equipment that's gone in, and the airplane from a very simple thing has become very complex. The most modern airplanes today cost something over $5 million, or 1,000 times more than they cost in 1917. This gives some indication of the increased complexity of aviation, and of course the improved performance and utility of aircraft today. But part of that, of course, is due to a reduction in the purchasing power of the dollar, but most of it is due to the things that have been put in the aircraft. Now, if we look at this airplane over here, we see a subsonic airplane flying at around 600 miles an hour, crossing the continent in about 5 hours. I see in the future the supersonic airplane that will cross the continent in something over an hour. And prior to that, there's a very large airplane, the Boeing 747, the Lockheed C-5A, which will greatly reduce the cost of air travel and tremendously increase the amount of air travel. It will have a profound effect on air cargo and the amount of air cargo that's carried. There will also be the VTOL and STOL aircraft that will make it more convenient to fly and will save time over short distances. All of these things are coming.
To study the heating problems generated by re-entry flight into the Earth's atmosphere, arc jet facilities were put into use at Langley. With the orbiting of the Russian Sputnik, getting men into space and returning them safely through the searing heat of re-entry became a high priority problem. Now, in the decade of the 60s, the Langley Research Center is charged with a dual responsibility: continue aeronautical research, and contribute to the science of spaceflight. A space task group originally formed at Langley went on to become the Manned Spacecraft Center. By the end of the Mercury program, there was no doubt that man could live and work in space. At the White House, President Kennedy awarded the Collier Trophy to the first 7 astronauts.
And I'm particularly glad that the decision has been made to award the trophy this year to them. I think it honors an extraordinary page in American history as well as in the history of flight. And I hope that this award, which in a sense closes out this particular phase of the space program, will be a stimulus to them and to other astronauts who will carry our flag to the moon and perhaps even someday beyond. So it's a great pleasure I present to them this celebrated award. Over here, all you gentlemen, touch it or lift it. Carry it away.
Here are some of Langley's other projects. Echo, an automatically inflating satellite, grew out of a Langley concept and was developed there. Rendezvous and docking, critical to the Apollo moon program, was studied and determined feasible. Commercial supersonic transport. The initial configuration was developed to meet the unique flight requirements. Lifting bodies. This, the so-called HL-10, craft which may someday shuttle men and equipment through space, then land like a conventional plane at an airport. VTOL, vertical takeoff or landing aircraft, forerunners of intercity transports which fly forward at high speed and then set down like a helicopter. The concept for this tilt-wing craft evolved into the first operational VTOL transport. Lunar Orbiter, a series of moon mapping craft surveying safe landing sites for American astronauts, conceived and managed by Langley scientists. Airport landing studies, and the list could go on. Langley Research Center. In 50 short years, it has risen from a few buildings and facilities testing out biplanes to join NASA's national effort in both aeronautics and space. But it's really 50 years of people. People make the machines and design the test facilities and plan the missions.